Welcome back to The Explainer. I am absolutely thrilled you're here today because we are looking at a massive shift that just happened in the second quarter of 2026. You know, we are officially past the era of just chatting with AI. We've completely entered the age of agentic autonomy. We're talking about delegating complex, multi-step execution to autonomous entities that can plan and orchestrate tools with barely any human oversight. Today, we're breaking down the two titans defining this whole new era: OpenAI's GPT 5.5 and Anthropic's Claude 4.7. We're going to use the data to figure out exactly how these systems are reshaping enterprise intelligence.
Okay, let's dive into this by immediately shattering a pretty massive misconception. If you're asking which of these models actually wins, well, you're kind of asking the wrong question. It's so easy to fall into that binary winner-takes-all mindset, right? But as you'll see, GPT 5.5 and Claude 4.7 aren't just the same product with different wrappers. No, they represent two completely different architectural philosophies about how artificial intelligence should actually function in the real world.
To really grasp what's happening under the hood, let's kick things off with Section 1, Architectures of Intelligence, and look at exactly how OpenAI and Anthropic took completely divergent paths to build these models. On one side, we've got GPT 5.5, which is built on this fluid, native omnimodal architecture. It's processing text, audio, video, high-fidelity images, all through one unified neural framework. It's designed for incredibly rapid cross-modal reasoning. But then, on the other side, we have Claude 4.7 Opus, taking a modular, high-res approach. Anthropic clearly prioritized rigorous, pixel-perfect visual precision over that fluid, single-pass omnimodality.
And just consider the capacity Anthropic built here. 3.75 megapixels. Claude 4.7 Opus can accept images up to 2,576 pixels on the long edge. Think about what that means for a second. This allows the model to act like a highly experienced senior architect, inspecting incredibly dense technical diagrams, massive software logs, or really granular document layouts. And it does it without losing a single detail. It is deliberate, it is careful, and it is highly analytical. But contrast that with GPT 5.5. The magic number here is 35x. Thanks to a major co-design with NVIDIA's massive GB200 and GB300 infrastructure, OpenAI achieved a staggering 35 times reduction in cost per million tokens. GPT 5.5 acts as this rapid-fire system administrator. It is so fast, so incredibly efficient, that OpenAI actually used its own agents to rewrite the deployment environment's load-balancing heuristics just to make it even faster. It is entirely built for sheer speed and raw throughput.
Now, what's really interesting about this slide is how these technical specs translate directly into cognitive behavior. GPT 5.5 relies heavily on ambient agency. Through its thinking and pro modes, it drives super fast pipelines by basically making reasonable assumptions to just keep things moving. Claude 4.7, however, relies on rigorous agency. If you set Claude to its new X-high effort level, it becomes hyper-literal. It prioritizes verification over everything, so it requires incredibly precise, literal prompts. Otherwise, it's going to pause and ask you clarifying questions rather than risk making a mistake. So how does all this philosophy translate into hard data and economic reality? Let's get into Section 2, Benchmarks and the Cost Divide. Take a look at these Terminal Bench 2.0 scores for multi-step workflows. Just notice that massive 13-point gap right there. GPT 5.5 scores an impressive 82.7% against Claude's 69.4%. When it comes to operating as an autonomous automation engine, literally driving a shell through complex tasks, GPT 5.5 absolutely dominates.
But the narrative flips completely right here. And this perfectly illustrates that doing versus thinking dichotomy we've been talking about. Claude 4.7 actually wins SWLens Pro with a 64.3% score. This benchmark tests resolving real production-level software issues on GitHub. Claude is just superior at deeply understanding the architectural implications of a code change, whereas GPT 5.5 is way better at the mechanical process of rapidly executing it.
But here is the catch: the hallucination paradox. When GPT 5.5 is pushed to the absolute edge of its knowledge in high-difficulty tests, it hallucinates 86% of the time. It's like a student confidently bluffing their way through a final exam. Claude 4.7, on the other hand, is highly calibrated. Its hallucination rate in those exact same hard tests is only 36%. Claude actually knows when to admit it just doesn't have the data, which makes it far more reliable for critical, highly regulated workflows like medicine or law. Yet for sheer volume, GPT 5.5 has a massive economic advantage. It is 72% more token efficient on coding tasks. Why is that? Well, because GPT 5.5 outputs what developers call tight diffs, literally just the code that needs changing. Claude 4.7 provides these highly verbose narrative explanations of why a bug occurred in the first place. And hey, that narrative is amazing if you're a human reviewing code, but it creates a massive cost penalty if you're running a high-volume automated pipeline.
So the crucial point is really in the economic breakdown here. GPT 5.5 charges a flat rate of $5 for input and $30 for output per million tokens, even for massive contexts. Anthropic actually penalizes really long prompts with a surcharge. This means GPT 5.5 is significantly cheaper for massive single-pass repositories. However, if you're building, say, customer service bots where the system prefix repeats over and over again, Claude 4.7's prompt caching can save you up to 90%. You absolutely have to align the pricing model with your exact use case.
Let's zoom out from the technical specs for a minute. Section 3, Safety and Global Access. We need to look at the geopolitical and security implications of these two models operating out in the real world. How do you actually secure frontier AI? Well, OpenAI uses a strategy called context-aware permissiveness. Through their Trusted Access for Cyber program, they actually lower the refusal boundaries for verified cyber defenders, giving them access to a specialized tool called GPT 5.4-Cyber for aggressive dual-use tasks like malware analysis. Anthropic took a completely different path called differential reduction. They actually have a more powerful model internally called Mythos, but they've deemed it too dangerous for public release, restricting it purely to government use. Claude 4.7 is their public-facing model, strictly safeguarded to act safely for general developers. So we are really seeing two completely divergent approaches to global AI safety.
And the global impact of all this is just fascinating. Consider this concept of AI sovereignty. It's the transition from hyperscale data centers to right-sized, localized ecosystems. At the Nairobi AI Forum in early 2026, Kenya really solidified its rise as Africa's prime AI hub. Through a massive trilateral partnership, they are distributing 1.5 million GPU hours to innovators specifically to tackle local issues like climate resilience, local language adoption, especially Swahili, and food security. But here is where you hit real-world friction. The frontier models we're talking about don't natively support M-Pesa, which is Kenya's dominant mobile wallet. Because of that, developers are forced to use wildly complex payment workarounds just to get access. Imagine trying to build a cutting-edge startup, but having to use U.S. Apple gift cards registered to Delaware addresses, high-authority virtual cards, third-party API resellers, and even crypto-to-fiat conversion platforms just to pay for API calls. It's a stark reminder of the commercial availability gap. The tech is globally transformative, for sure, but the financial infrastructure is still catching up. Which brings us to the climax of our explainer today, Section 4, the multi-model strategy. Let's see how enterprise leaders are actually applying both of these models in perfect symbiosis. This routing table right here is exactly how successful organizations are operating in 2026. They've totally abandoned the winner-take-all mindset. Got high-volume automation? Route it to GPT 5.5 for that raw speed and efficiency. Need deep code review and refactoring? Send that straight to Claude 4.7 to get that rigorous architectural judgment and narrative explanation. What about abstract math or high-stakes complex logic? Pass it to GPT 5.5 Pro using parallel compute. It is all about delegating tasks based on the model's respective strengths. Let's move to and see how this builds into an actual industry-standard workflow. It's something developers are calling the handoff hack, and it's brilliant. Step 1, you pull real-time data using a search-optimized engine, like Perplexity. Step 2, you feed that data into Claude 4.7 to draft a high-level rewrite plan or document, heavily relying on its deep reasoning skills. Step 3, you pass that finalized plan right over to GPT 5.5 for rapid, token-efficient execution. You are literally combining Claude's architectural brain with GPT's incredibly fast hands. And you know, these workflows map perfectly to the corporate trajectories of the companies themselves. For 2026, OpenAI is leaning extremely hard into their capital-intensive Stargate initiative. They're aiming for $600 billion in compute to essentially build the ultimate operating system for all knowledge work. Anthropic, on the other hand, is focusing squarely on commercial monetization, B2B reliability, and preparing for an IPO with a very clear path to being free cash flow positive. They're building very different businesses, and consequently, they're giving us very different tools. Which leaves us with the ultimate question. Does your organization have an architecture for one AI or an ecosystem for both?
The absolute most capable agents of 2026 are composite systems that harness the brilliance of both the OpenAI and Anthropic frontiers. It's time to stop choosing a single winner and start building a smarter routing system. I hope this explainer helped you map out exactly how to do that. Keep learning, keep experimenting, and I'll see you in the next one.